All right, today we're going to work on finding equations of exponential functions. So what we've been working on in class has been, we did the dice activity. So you were finding equations of exponential functions with that, but you were calculating what the growth factor was, whether you were adding a portion to your group of dice or taking away a portion. You had enough information to figure out what your growth factor was. And then in the word problems that we did, again, you had enough information whether it was interest that you were gaining on money or if it was a population growing or decaying. You had information about the growth factor. Okay, so what we're going to focus on more today is well, what if I don't have that information? How do I write an equation for an exponential function then? Okay, so starting out here, exercise 1. The data in the table is information about an exponential function. So you'll notice here with this first term, 0, 5, this is your initial amount. So just like when we did the dice activity, it was, okay, you're going to start with 5 dice, and then you're going to roll those dice, and whichever ones are odd, you're going to add that many more to your group. Okay, so when we started out, 0 rolls, you started with 5 dice. So 5 is our initial value, and that's our A. Okay, so initial value. All right, your B is your growth factor. Okay, whether it's increasing or decreasing, that tells you about your growth. Well, we're not given our growth, but we are given these ordered pairs that follow this pattern. So if you look at your y values or that f of x value, if you go from 5 to 15, that is, you're going to multiply by 3. If I go 15 to 45, you multiply by 3 again. Okay, 45 to 135, multiply by 3. Okay, so if you can see that consistent pattern, multiplying by a value, that tells you you have an exponential growth or exponential decay. Okay, so in this case, our B is going to be 3 because I multiply by 3 each time. Okay, well, what happens if it's a decay instead of a growth? So, for example, if you'd have the same kind of situation, okay, but this time, let's say 0 is 48, 24, 12, 6, and so on. Okay, so this time, to go from 48 to 24, I divide by 2. Okay, 24 to 12, divide by 2. 12 to 6, divide by 2. Okay, so my pattern is divide by 2. Okay, but your growth factor, whether it's increase or decrease, growth or decay, don't think of it as divide, think of it as multiplying. So if I'm dividing by 2, that's actually the same thing as multiplying by 1/2. So to go from 48 to 24, multiply by a half. 24 to 12, multiply by a half. 12 to 6, multiply by a half. Okay, so in this case, it would be an exponential decay, but your B, my growth factor, would be 1/2. Okay, so even if you're saying, hey, I see that I'm dividing by 3, okay, think of it as, okay, turn that around, multiplying by 1/3. All right, so back over here, what is our final equation? Y equals A, which is 5, times B, 3, to the x power. All right, so this kind of takes us through the same process. The information we have here is f of 0 is 8, and f of 3 is 1,000. So f of 0 is 8, that's the ordered pair 0, 8, and f of 3 is 1,000. There's your ordered pair 3 and 1,000. Okay, use the fact, part A, the fact that f of 0 equals 8 to determine the value of A. Well, remember, A is that initial value. How much do you start with? So if I'm starting at 0, okay, 0 is 8. So my initial value is going to be 8. So that's one piece that we need to be able to write our exponential equation. So we know our starting point is 8. Okay, then the other piece of information we have is the ordered pair 3, 1000. Well, I need to find the value of B. Okay, but again, I don't have enough information or the right kind of information that I see what the value of B is right now. But you do have this other ordered pair, the 3, 1000. The 3 is your X coordinate and your 1000 is the Y coordinate. So I'm going to take that point, that 3, 1000, and we're going to plug it in for the X and the Y. And now we have enough information we can solve for B. Okay, to solve for B, I'm going to divide by 8, and B cubed equals 125. Okay, so part C, I guess I got a little ahead of myself. So part B was just write the equation that you're going to use, and then part C is solve it. So I would do 1000, I would divide by 8, and this would give me B cubed equals 125. And now I can cube root, and B is 5. Okay, so now that we found 5 is my growth factor, my equation would be y equals a times b to the x. So there's my exponential equation. Now D takes it a step further. It says, okay, so find the value of f at 2. So I would just plug in 2 for my variable. So this would be 8 times 25, or 200. So f of 2 is 200. Okay. All right, here again we are given two pieces of information. F of 4 is 3. So you can think of that as the ordered pair 4, 3, and then 6, 48. Which of the following must be true of its base? Okay, the base, we've been calling it the growth factor, which it is. But when you look at this equation, a times b to the x, okay, b is the base of that exponent. Okay, so when it says what's the value of the base, it's looking for that b or that growth factor. Okay, we're given a couple pieces of information, but again, we don't really know what b is. But look at what we do have. We have 4, 3. We don't know the value at 5, but we know the value at 6 is 48. Okay, so remember back up here at the beginning, we kind of looked at this table and said, okay, so what would I do to get from 5 to 15 to 45 to 35? And it would be multiply by 3 each time. Okay, well here we have that same kind of thing. So I'm going to be, it's increasing. I go from 3 to 48, so it's going to be a growth. So I'm going to multiply by 3 by something to get to that spot where 5 is, and then that value multiply times the same thing, and that's going to take us to 48. Okay, well, it's kind of nice. We've got multiple choice, so we can kind of see which one's going to work, and it's going to be 4. So if I do 3 times 4, okay, 3 times 4 would take you to 12, and then 12 times 4 would take you to 28. So that fourth option is the one that works. Okay, let's look at example 4. Again, we're given 2 points, and we're going to be writing a system of equations and solving them. Okay, so this is going to look kind of weird to you. You did do this in Algebra 1. You solve systems by graphing them, finding the intersection point. You use substitution, and you use linear combination. This method's a little bit different. To start us out, we are going to take each of our ordered pairs. Okay, they're both an x coordinate and a y coordinate, and we're going to plug them into our exponential equation. Okay, so I'm going to do that second point is going to be 121.5 equals A, I don't know, B, I don't know, but the x is 5. Similarly, with our other point, we're going to go 36 equals A times B squared. My x is 2. Okay, so I've written my system of equations. So part B, we're going to divide the two equations to eliminate the constant A. So these two equations, 121.5 equals A times B to the fifth, and 36 equals A times B squared. Now, when you divide equations, again, this is going to look kind of strange to you. When I divide, those A's are going to reduce out. Okay, B to the fifth divided by B squared. Well, if you remember your exponent rules, when I divide with like bases, you subtract exponents. So 5 minus 2 is going to be 3. And then 121.5 divided by 36 is going to be 3.375. Okay, so we divided those, and I have this equation. So part C says, okay, solve for B. So B cubed equals 3.375. I'm going to do cube root of both sides, and B is actually 1.5. Okay, so there is our growth. So right now I have y equals a times 1.5 to the x power. So now all I need is to figure out what a is. Okay, to do that, we were given 2 points to start with. I'm going to use the 2 and 36. Okay, so again, we have an x and a y. So if I plug in those values, the y is 36 equals, I don't know the a, 1.5, and the x is 2. So this becomes 36 equals a times 2.25. And if I divide both sides by 2.25, a is 16. So now I can write my equation, a, 16, my initial amount, times 1.5 to the x power. Okay, so there were a lot of steps in there. In the next video, I will go through a couple more examples doing this, and we're going to line out, kind of make a list of what all of our steps are to find our values for A and B.